This is Brooke Hedrick testing the Contextual Electronics PowerSwap 5.5 volt output version. We're going to test today the PCB you see in the lower left hand corner. On that PCB there's a red and black set of probes. Those are the way we're getting the voltage into the PowerSwap. That's the input. That's also how we're going to be measuring the amount of current being drawn in to the PowerSwap. And you'll see a meter for that in the upper right hand corner of your display. And then within that same PCB board where the green and yellow wires are hooked in, that's the output to the PowerSwap. And if you look on your screen on the right hand side, there's an output voltage /FB display. That one is the regulated output, and we're looking to hit 5.5 volts there. Right now everything is not bringing power into the PowerSwap, so the numbers you're seeing aren't relevant. On the bottom right hand corner is a scope showing the output signal, so that way we can see what the regulated output signal looks like coming from the PowerSwap. And then the upper left hand corner is the numbers for the DC load we're using. So we're going to start off with no load, so you'll see how the load says off. When I turn the load on, you'll see it switch to either on or CC, so current controlled. And we're going to start off, once that happens, at about 50 milliamps, and we're going to work our way up and see where and if we lose the ability to keep our 5.5 volt regulated output. Our input voltage for this test is 3.7 volts. We're wanting to check to make sure that our LiPo battery, which will generally sit around 3.7 volts, is going to be able to power this circuit. I'm going to plug the power into the circuit now to give our 3.7 volts input to the PowerSwap. As you can see now, we are getting our 5.5 volts regulated output. We've got a signal now showing up on our scope in the bottom right hand corner. Not very interesting yet, probably because we don't have any load. But we also can see we're drawing about 115 milliamps at the input. So that 115 milliamps is coming to us at no load. So just to power the board and get that 5.5 volt regulation out of our 3.7 volt input, we're already burning 115 or so milliamps. I'm going to turn on the load. You'll notice the upper left hand corner, the off switch to CC, and now we are drawing an additional 50 milliamps at the output. So we actually have a load going. It looks like it cost us about 100 milliamps to get that 50 milliamps. So right now for 50 milliamp output, we're consuming 200 and some milliamps of current. I'm going to start turning up the load and see at what point we lose our 5.5 volt output. We're still going. We're getting close to falling off the edge there. We're at 120 milliamps load. We're barely hanging on at 180 milliamps. Okay, there it fell back. So 200 milliamps is too much. 190. Looks like 180 milliamps is what we can draw at 5.5 volts before we're going to lose our regulation. So that ends my testing of the load capabilities of our PowerSwap when we're trying to get 5.5 volts out. I'm going to quickly make a change to the output display over there on the right. Instead, we're going to look at the feedback values. We're expecting to see about a half a volt. So hang on while I make a quick change. All right, now I have a probe I'm going to connect to the feedback test point. And there you go. we're seeing that approximate 0.5 volt feedback value that we were expecting. Well, that ends my testing of the Contextual Electronics PowerSwap 5.5 volt output version. This has been Brooke Hedrick. Thanks for watching.